Good morning. Happy Friday. We've made it through our first week of school. We are on our new topic for today. Yesterday we talked about perfect squares and their square roots. And so today we're going to take it one step further and talk about square roots that are not perfect squares. Okay, so how would we evaluate their solution? So again, a perfect square we talked about yesterday are those nice pretty numbers that when you square them, you get a whole number. So for example, 1 squared is 1, 2 squared is 4. Again, the list can go on. These perfect squares, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. So again, these are our perfect squares, and then if we were to work backwards, the square root of 1, we would get 1. The square root of 4, we would get 2. The square root of 9, we would get 3, and so on. Square root of 16 is 4. Square root of 25 is 5. And the square root of 36 is 6. And we could keep going if we wanted to, all the way down to 15. Okay, I will say that knowing those perfect squares will help a lot with approximating the square roots. Okay, so if you haven't done so, there's an activity in your interactive notebook to help you practice those perfect squares. And again, it'll make it a lot easier for you. So let's go and look at an example problem. So let's find or approximate. Again, approximate is this another word for estimation or estimate. So the approximation of the square root of 35. Okay, now since the square root of 35 is not a perfect square, meaning it's not 1, 4, 9, 16, 25, or 36, okay, we know that we're not going to get a nice pretty whole number. Okay, now the square root of 35, since it is not a perfect square, makes it irrational, meaning I'm going to get some type of decimal that's going to keep going and continue going without repeating and without terminating. So if I were to have to evaluate the square root of 35, I need to be able to give an approximation of where it might be on a number line, or what number it's going to fall between on a number line. So here, the square root of 35. I'm going to look here and see where 35 might fall. Now again, I could continue, but I just stopped here. So 35, okay, falls between 25 and 36. Okay, so I can say that the square root of, it falls between the square root of 25, so it is greater than the square root of 25, okay, but less than the square root of 36. Okay, so then if I were to actually take the square root of 25 is 5, again, greater than, and the square root of 36 is 6. And so I know that it has to be less than that. So the square root of 35 is going to fall somewhere between the integer 5 and the integer 6. Now, we don't know an exact placement of where it would go, but if I were to estimate, halfway between 5 and 6 is 5 and 5/10. Okay, but we can even take it a step further. Which value is 35 closer to? Is it closer to 25, or is it closer to 36? Here, there's only a one number difference here. So I would say that my square root of 35 is going to be closer to, and again, if this was a number line, and I said here's 5, and here's 6, and here's 5 and 5. Since the square root of 35 is only one number away from the square root of 36, which is 6, I would probably estimate that the square root of 35 is probably about 5 and I would say maybe 9/10. Okay, because it's closer, 35 is closer to 36 than it is to 25. And then you can always come in the calculator and check. Okay, so we can put in the square root. Now again, to get this square root, I would have to hit second and the squared button. So the square root of 35. And we said approximation. We know it's between 5 and 6, but a better approximation we would say is about 5.9. And let's see. And exactly, I get 5 and 91 hundredths. So again, we're not looking for the exact number. Okay, we're just looking for an approximation as to where it might fall on the number line. Okay, so let's do example number 2. All right, so example number 2. Okay, we're going to approximate the value of the square root of 17. Again, so we're looking for an approximation. We can go ahead and list out our perfect squares if you want to help you a little better. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And again, you can kind of stop when you know, again, if my number is 17, I don't really need to go past 25. Okay, so again, we have our square root of 17. Okay, we know that it's going to fall between 16 and 25. So I know that it has to be, I'm going to put the square root of 16. I know it has to be greater than the square root of 16, but less than the square root of 25. Okay, and so the square root of 16 is 4. So I can bring that down. The square root of 25 is 5. Okay, so we can say that the square root of 17 is going to fall between 4 and 5 on the number line. So if I were to draw this number line here, and I said here's 4, 5, we would say again we could estimate that the square root of 17 is going to fall somewhere between 4 and 5. And then, so again, we would have about 4.5, but we could take it even a step further. The square root of 17, or 17 is closer to which number, 16 or 25? Okay, so the square root of 17 is closer to 16. So I could, and the square root of 16 is 4. So I could say that I'm going to approximate that since it's closer to 16, I'm going to approximate that it's probably going to be about 4 and maybe 1/10. Okay, if I were to have to plot that on the number line. And so again, we can always come and check with the calculator. So if I said the square root of 17, I get 4 and 12 hundredths, which again is close to 4 and 1/10. Okay, so this is a pretty good approximation. If the question were to say what two integers the square root of 17 falls between, then you know the falls between 4 and 5. Okay, so they might not ask for the exact approximation. They might just ask what two numbers or what two integers does the square root of 17 fall between. Okay, one more. I'm going to get a new piece of paper. Okay, so if I had to approximate, say the square root of, let's say 52. Okay, so again, I'm going to list my perfect squares. Okay, and as you keep doing this, you're going to start memorizing them and it'll be a lot easier. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And again, I want to keep in mind 52 because I don't want to keep going if I don't have to. 5 squared is 25, 6 squared is 36, 7 squared is 49, so I'm getting close. 8 squared is 64. All right, so here I know that 52 falls between 49 and 64. So the smaller number is 49, the bigger number is 64. So I can say that the 49, square root of 49, is less than the square root of 52. I'm sorry, is greater than the square root of 52, but less than the square root of 64. Okay. Now again, we know that the square root of 49 is 7. And we know that the square root of 64 is 8. So again, it's kind of, even if you write them out, it kind of lends itself to helping you, because then you can just look back at this little section right here. So I know that the square root of 52 has to be greater than 7, but less than 8 on the number line. Okay. So again, it falls between these two integers, 7 and 8. So if I were to look at this on the number line, I have 7 and 8. I know it's going to fall somewhere in the middle. Again, a broader approximation would be 7 and 5/10. But if I did want to take it a step further, and I can look at, okay, well, which number is 52 closest to? Is it closer to 49? Or is it closer to 64? And if you're unsure, you can just look at these numbers and kind of subtract. You can find the difference between these two. So let's say 52 minus 49. And again, you can use a calculator. So the difference here is 3 versus, let's say, 64 and 52. We can find this difference, 64 and minus 52. Okay, and so the difference is 12. So I would say that 52 is a lot closer to 49 than it is to 64. So that means if it's closer to 49, then it's going to be closer to the positive 7 here. So, and it's 3 spaces, or it's 3 numbers away. So I would say maybe it's about, I don't know, halfway between 7 and 5/10. So I'm just going to say 7 and I'm going to say 3/10. Okay, it could be a little smaller, it could be a little bigger, but again, it's an approximation. Again, we're not looking for an exact value. We're just looking for an approximation. Where is it closest to? So again, I can get my calculator, and I can say, so the square root of 52, and so again, 7 and 2/10. So again, I wasn't off by much. I was just off by 1/10, but again, it is an approximation. Okay, so hopefully this video helps. I look forward to seeing you at the live Q&A at 10 and 2, but please make sure if you have any questions to let me know. All right, have a great Friday.